All right, class, I have a special couple of examples to work out with you. This will be great practice in preparation for our test next week. This is in supplement to the lesson that we had today, which is Thursday the 25th. Our learning goal and objective is to solve a system of equations by elimination. So we're going to do the warm-up question right here. 6x plus y equals 25. 9x minus y equals 20. We want to solve this using the elimination method, right? And we know that we can use the elimination method when we have a variable, any variable, that can be automatically eliminated when we combine the equations. So what you want to look for is different signs. So like this one's a positive, this one's a minus, but the same coefficient. In this case, the coefficient is 1 because nothing is there. So there's an imaginary 1 right there. This would also work if the coefficients were both like 2 or 3 or 4. They would all be, that can be eliminated. Okay, so look for different signs, same coefficients, and then guess what? Automatically, you get to eliminate those variables. Boom, boom. So using this method of elimination is really like a shortcut when you combine the equations. Now, let's combine the other terms. We have a positive 6x, a positive 9x. Well, 6 plus 9 is 15. Drop down the equal sign. 25 plus 20, that is 45. There we go. Divide by 15 on both sides to get the x by itself. And just like that, we already have one of our variables. So half my answer is already there, right? So my x value is 3. We're missing a y value because remember the solution to a system of equations is a coordinate point, x value, y value. Since we know x, now I just gotta solve for y. And this is where a lot of students get kind of stumped. They're like, okay, what do I do next? Well, you plug in that 3 to the x value of either of the equations. Either one will work. You only need one of them, all right? So it's your choice to use a certain equation. I would really recommend you guys making it easy on yourself. Do the top equation because one, the y is positive and it's just by itself because that's just a plus y, remember? And two, you don't have to divide by anything. If we did the bottom equation, we would still get the same thing, but see the negative right there, that's technically a -1. Well, we can't have the variable be negative, so at the very end of solving, we would have to divide everything by a -1, essentially an extra step. So either equation will work, but I'm going to use the top equation here. I'm going to rewrite it. 6x plus y equals 25. I know what my x is now. It's 3. So I'm going to plug in 3 for x. 6 times 3 is 18 plus y equals 25. And this is what I was talking about. If I subtract 18 from both sides, I get 7. And my y is all by itself. I don't have to divide by anything because it's positive. Boom, I just found that out. So my solution to this system of equations is 3, 7, and I use that using the elimination or linear combination method. Okay. Now we're going to compare that to substitution. All right, you guys learned substitution previously before elimination, and I've gone on record to say that the reason why we teach substitution first before elimination is because it is harder and longer. So we want you to learn how to use substitution before moving on to the relatively easier method of solving, which is elimination. All right. So when you solve by substitution, the key that you're looking for is there a variable all by itself on one side of the equation? Well, let's look at the top equation. Y plus 2x equals 10. No, there's y and x on the same side. X equals y minus 4. Well, there's a -4 with the y, but look at that. My x is by itself. So yes, this is a perfect candidate to solve a system with substitution. All right. So what I recommend is after the variable is all by itself, put parentheses around the expression, whatever it is. In this case, it's y minus 4. This y minus 4 is what we will be substituting into the x of the first equation right there. All right, So if x is equal to this expression, y minus 4, I can substitute it, y minus 4, into that x right there. So let's rewrite the equation. Y plus 2. Now once again, instead of x, I'm going to put what x is equal to. Y minus 4 equals 10. Okay, the 10 didn't change, the y didn't change, obviously, but now, since I have one total variable, there's only one total unknown, I can solve. Boom, boom. Distributive property to get rid of the parentheses. I have y plus 2y. 2 times negative 4 is negative 8 equals 10. Now I am just simplifying, all right? So let's combine the like terms right here. Y plus 2y is 3y minus 8 equals 10. All right, another step, isolate the variable. Let's add the 8 to get rid of it, because we got to do that. We want all the variables on one side, numbers on the other. Add 8. I have 3y equals 18. Divide by 3 on both sides. Y equals 6. Whew, take a deep breath. I know you guys remember this too, right? So after all that work, I was able to find half my answer. Now my y value is 6. I was able to find my y value this time. To compare that with elimination. Like, I did a lot of work, essentially. Now, if you're good at algebra, if you're good at equations, this is a piece of cake. I personally enjoy doing equations like this because it's so, like symmetrical. Like, you know, a nice little V shape, and you know that you're gonna come at the very bottom with the answer right there. So, but now that we know it's a coordinate point, we have to find our x value, right? Because we only have half the answer. What's nice, and this is where elimination and substitution are the exact same. Once we have one value, right? Once we have one value, we just plug it in to find the other one. Okay, that's where both of these methods are the exact same. If I know my y value is 6, well, I'm just going to plug that in to find my x. If I know y is 6, here we go. Well, this is super easy. X equals, well, instead of the y, now I'm going to put what it's equal to. 6 minus 4. Well, that's super easy. X equals 2. So my coordinate pair, my solution to this system, the second one used by substitution, is 2, 6. That's where these two lines cross. Okay. All right, I'm going to do one final question. I'll leave that to you guys right there. Please remember, homework over the weekend is on clever.com. There's only 6 questions, and it's all on the elimination method of solving. All right, so make sure to do those 6 over the weekend. It's on clever.com. All right, one final example we're going to use. Let's take a look at this. We have negative x plus y equals 9, and then x plus 2y equals 6. Okay, interesting. Which method would you think this is best to use? Elimination or substitution? Well, I can tell you right off the bat, it's going to be, elimination, because let's look at the y variables. Okay, they're both the same sign because they're both positive. They don't have the same coefficient. Look at my x's, though. This is a negative x, essentially a negative 1x, and this is a positive x, a positive 1x. Oh, different signs, same coefficients. We can definitely use elimination. All right? We technically could use substitution if we want. If we got one of these variables by themselves, for example, if we added the x to the top equation, added the x over here, we would have the y by itself. Then we could use substitution, right? But like you said in the previous example, substitution is a long way to solve. If we could use a shortcut with elimination, it'd be a little quicker. All right, so we will use elimination right off the bat. We're kind of fortunate we can eliminate the x's. Sometimes we will manipulate equations by multiplying everything by a constant to be able to eliminate. But right now, automatically, look, those can be eliminated when we combine the equations. All right, so y plus 2y, okay, is 3y. 9 plus 6 is 15. Divide by 3 on both sides. I already figured out that my y value is 5. All right, so part of my final answer is, we don't know the x value yet, but I do know my y value. as with the previous problems, once I know one of the, what are the answers, what are the values, I just plug that in and solve for the missing variable, all right? I'm going to solve for the x. I could use the top equation or the bottom equation, but just like one of the previous examples, I'm going to use the bottom one this time because my x is positive. It's already, there's no coefficient, it's positive. I'll just plug in the y and boom, I'll be able to solve it much quicker. I could use the top equation, but after I plug in the y and get everything done, I would have to divide everything by a -1 to make sure that x is positive. So if you want to make it a little easier on yourself, just use the bottom equation, x plus 2. Now instead of the y, I'm going to put what the y is equal to, which is 5, equals 6. X plus 10 equals 6. One more step, get that x by itself, and I don't need to divide because it already is by itself. Subtract the 10 from both sides. -4, booyah. So just like that, I solved another system of equations with elimination this time. All right, thank you guys for watching. Please go to clever.com for your assignment. You guys are amazing.